guys, I'm Manisha Miriala. In this course of mobile computing, we as a team 4 developed a project which deals with benchmarking of machine learning algorithms. This is our UI of our project. As you can see, the first input field is the seek bar, which partitions the data based on the user given input. Here this says that this partition of the data is being trained and the other part of the data is being tested. The other field is to choose the nearest k number of members of the k nearest neighbor, which deals when you select the KNN algorithm. The others are the four radio buttons of four classifier algorithms which we developed. Let's have a sample run. I'm selecting the decision tree classifier and I'm training the data. Once the data is trained, we'll get these outputs. So the above are the error times and the below are the execution performance of the decision tree algorithm. The upload data will upload the data into the cloud button in the UI deals with the data which is uploaded and displays it on the cloud. It also displays the computations on that data. Let's click on view on cloud button and select the browser. So the Colab is the cloud which we are dealing with and all the data will be uploaded into the Colab drive. You can say it, these are the methodologies which we have implemented on the cloud. These are the classifier algorithms and you can see the results. The accuracy of the decision tree algorithm is 63.95. The RMSE is this and so on. So this is the view on cloud button. And as you already know, when we train the data, these are the values which are printed into a log file. And we have implemented a specific function which is run algorithm on GPU, but we have implemented on the random forest algorithm. So whenever we click on run algorithm on GPU, it will give the results which are faster than the normal trained data.
Hi guys, my name is Amanjot and I am part of team 4 in our mobile computing course. I'm going to give a code walkthrough of our final project. So I have worked on the basic layout of the application, creating the general functionalities like distributing the data into training set and testing set, and then showing the final output on the result page. And apart from this, I have worked on the algorithm KNN. So I will first give the code walkthrough how the application works. So this is the first page that gets loaded when the application starts. So you can see I have implemented the values to select which algorithm the user wants to select, and then I have created this seek bar which is to distribute the data between training set and testing set. And then this is the classify button handler in which I have created different sections for others to implement their algorithms. So if you look at the ML helper class, this is the class which distributes our data set into training set and test set. And our data is in the form of .arff format. So I have created this class where the other team members can call this and it will read the attributes from this data set. Then I have created this result page where we are trying to display the results, and I am also creating a log file as per the requirements of the project. Now if we go in the KNN, I have used Veka's classifier IBK, which is for k-means algorithm, and I am calling my classes that I created and distributing my training set and testing set, and then I am calling this classifier of the Veka algorithm and calculating our model. So here I am capturing all the information that the algorithm has calculated, and I have the getters for this information. so that we can call it in the main activity. Here I am writing this whole data in the log file. I have created this method at the end to write in the log file. Okay. This was my contribution to the project. Thank you.
Hi, my name is Sakshi and I'm a part of Team 4, and our project for CSE535 was benchmarking machine learning algorithms, in which we used 4 algorithms: logistic regression, random forest, gain and decision trees. And the dataset that we chose was breast cancer dataset, which we found in the UCI library. So what logistic regression basically does is that it is a supervised form of learning, and then it fits the model into a logist function, which is very accurate, and it's way more accurate than linear regression. And the process is as it goes. This is method. So first we create the instances of the test set and the train set. Then we use the logist classifier and we build the model based on the training set. And here we evaluate the test set. So the next part is the setters and getters, which are used to get the values of the true positive rate, the false positive rate, the true negatives, the false negatives, the RMSE, the HDR, and the execution times. The next part of the video is my functioning on the cloud platform. So this is a Colab library, the Colab tool, which is offered freely by Google, and it has instances of Jupyter notebooks which are running on the cloud. So what we used is random forests in order to determine this. Here are some of the libraries that I imported. Then I imported the file and converted it into CSV. So after that I transformed it into categorical values, so that into numerical values, so that the forest classifier can take it. And here it's dividing the training data set into test and gain. And here I'm fitting the model, random forest classifier model, and it's predicting the data. So these are the true positives, the true negatives, and these are the false positives and the false negative. And it has an accuracy of 64% and RMSE of 0.6.
Hello guys, I'm Masha Miriala from Team 4. In this project of benchmarking machine learning algorithms, I have implemented the decision tree classifier algorithm. The decision tree classifier takes each feature and classifies the dataset based on the class which we are predicting. Let's see the code. The DT is the button which takes the ID of the decision tree radio button in the UI. Whenever the DT is being checked, the decision tree object is created. And you can also see the decision tree object accesses the process function with the instance, the train size, and the test size as its parameters. As we've already seen in the demo, the train size and the test size are the parameters which are taken from the user input when he drags the seek bar in the UI. And the process function in the decision tree class deals with the ML helper. It first takes the help from the ML helper and sets the training data and the testing data based on the size which is sent as a parameters. Also, the decision tree classifier class here performs the computation and generates the values of the training time, testing time, the total execution time, along with the error rates such as statistic, root mean squared error, mean squared error, total number of instances, etc. Along with that, the decision tree class also generates the true positive rate, true negative rate, etc., which are the execution performance, and results it to main activity again. One thing you should notice is the toSummary string is the inbuilt function of the classifier, where we have included here the classifier is the new REP tree. The REP tree is the inbuilt classifier of the decision tree in Weka. Once these all values are returned to the main activity, we are plotting them using a log file. So whenever these data has been returned, the write to file function takes the write data, which is a string, which has all rates the execution rates and execution times and also the error rates, will load that write data to the main activity of to this context and writes that file to the string builder. This output stream writer has all the log data information and prints it in the second screen of our app. Thank you.
Hello guys, my name is Narendra Mohan and I am from Team 4. So the part that I've done in this project is implementing the random forest algorithm in this app. So as you can see in the code, the variables for the train time, test time, the false positive rate and false negative rate, true positive rate, true negative rate, and the execution time are being declared here. And the basic functionality of the code is that the ML helper function is your class is used to create an object and then used to initiate the process. The instances for training set and test set are created, and then the classifier is declared and called upon, and then evaluation of the model is done based on the training set and the testing set. And then the corresponding numbers are calculated for the algorithm, and then they are returned to the main activity.java class using the getters and setters. So the next functionality that I had implemented was the upload button functionality and then the view cloud functionality. In first, let's see the view cloud button. So what happens is, first we'll check whether any of the algorithm is selected, and then only then will it allow the button to be performed. So we are here giving the link to the cloud service where the computation is done by Sakshi. So the website is of Colab, which is hosted by Google, and then it is redirected to that website. And then the upload functionality, we can see that if the upload is successful, we will see a toast, and then the upload started and complete, and then error functionalities are showed in the form of an error or a log. So that's it guys, thank you.